Okay, I'm here in 8.1, day 10 CAMI assignment. We're still solving systems by graphing. And number one here, these directions apply to all problems. So if the equations are not already in slope-intercept form, you need to show all of your work to get them in slope-intercept form. And then when you graph each line, remember to begin with B and move with M. Find the point of intersection if there is one, and where the points intersect, that ordered pair is the solution to the system. So number one right here, both of these equations are already in slope-intercept form. You have y on one side, everything else on the other side, your x term listed first, and then your constant. So the number in front of x, that's going to be your m. This is going to be your b. So begin with b, move with m. Remember, this negative sign can be put in the numerator or in the denominator, right? So you can write it as negative 1 over 3, right? That would mean go down 1, right 3, or you could write it as 1 over negative 3. It doesn't matter whether you put it in the numerator or in the denominator, just as long as you put it in one of those instead of just out front. And in this equation, negative 2 will be your m, and negative 3 will be your b. Okay, so begin with b, move with m. Because these have different slopes, we know that if the equations have different slopes, we know that there will be one point of intersection. And so there will be one solution to this system. So you try that one. And number two, here we have this system. Okay. And what this little bracket means is just this is a system. These equations work together. Okay, so we have equation 1 and we have equation 2. And neither one of them are in slope-intercept form, and so we'll need to rewrite them into slope-intercept form. So equation 1, I'll put a little 1 and circle it. I'm just going to copy down what it says. X minus 2y plus 8 equals 0. Okay, so I need to solve for y right here. So I need to move the terms around so I have y on one side and everything else on the other side. Now, I know my y term is on the left side of the equal sign, and so I could, of course, move x to the right side and move the constant 8 to the other side. Okay, but that would mean me moving two terms instead of just one term. So how about instead I move this y term to the right side? That way the y term will be by itself. And so to move the y term over here, I would undo this subtraction by addition, right? I would add 2y, of course, to both sides. So that those y terms will cancel. So on the left side, I have x, and I have a plus 8. So I bring those terms down. Now bring my equal sign down. Bring the equal sign straight down. Bring your equals sign straight down. Bring your equals sign straight down. Don't forget your equal sign. 0 plus 2y is 2y. Okay, now I need to solve for y, so divide every term in the equation by the number in front of y, which is 2. So I'm dividing every term in the equation by 2. Okay, I'm doing that so that these 2's will simplify to 1y. And so I would have 1y. I'm going to go ahead and put the y term over here first. So y equals, okay, now remember what number is in front of x? There is an invisible 1 there. And so what fraction is this? If I have a 1 on top and a 2 on bottom, 1 over 2, that is 1/2, right? So this is 1/2 x. Don't forget your x term. So this is x, 1/2 x. Okay, then you have this, which is 8 over 2. 8 over 2 is positive 4. So this right here is the equation in slope-intercept form. Now you can identify m and b. M is the number in front of x, and so that is 1/2. So this is 1 over 2, 1/2. And b is this constant term, which is a positive 4. So b is 4. Let's go ahead and graph this line. So I would begin at b. B, of course, tells me where the line crosses the y-axis. This is the x-axis. This is the y-axis. And so line 1 crosses the y-axis at 4, right? Positive 4. That's where the line crosses the y-axis. And then we're going to move with m. M in line 1 is 1/2. Okay, and this would tell me to go up 1 and right 2. Okay, so if I do that from B, if I go up 1, right 2, I would be right there. Now, if I try to do that again, I'm obviously going to be off the grid. And so let's change the direction that we move. Let's instead let's, instead of going up, we go down. And instead of going right, we go left. So down and to the left, if I do that with my line, from B, I go down 1 and left 2. And there would be a dot. Okay, so let's go ahead and make our line here. I'll go Shapes, Insert Line, and click and drag. Okay, so it looks something like that. And of course, arrows on the end of the line to show that the line continues in both directions forever. And put a little 1 and circle it to show this is line 1 that comes from equation 1. All right, so we graphed equation 1. Now let's graph equation 2. So it's not in slope-intercept form either. So I'm going to write it over here, put a little 2 and circle it. And I'm going to copy this equation down so that I can put it in slope-intercept form. Okay, so be sure you copy it correctly. Copy it correctly. Let's solve for y. Y is on the left side, so get this 6, this -6, to the right side by adding 6. I got to add 6 so that -6 plus 6 cancels. So, of course, I add 6 to both sides. Those cancel, and your y term here is not 2y. This is -2y. So I bring it down, -2y. I bring my equal sign down. You got to write your equal sign. Bring your equal sign straight down. Then your x term is negative, so -x, -x, and this is a +6. Okay, this is not slope-intercept form yet. I have to solve for y, so I divide every term in the equation by the number in front of y, and the number in front of y is not 2, it is -2, and so I divide every term in the equation by -2. Every term in the equation gets divided by -2. Every term in the equation gets divided by -2. That way, these -2's simplify to 1y, or just y. And so y is equal to, remember here, there is an invisible 1 there. So if you want to make it uninvisible, go ahead and write it there. So this is a -1 over a -2. Well, anytime you have a negative over a negative, or a negative divided by a negative, you know that same sign's positive, right? It's going to give you a positive number. So this is going to be 1 over 2. 1 over 2. That is the fraction 1/2. Notice this is not 2. This is not 2 over 1. 2 over 1, yes, would be 2. But this is 1 over 2, or 1/2. Don't forget your x. So this is 1/2 x. And then here you have 6 over -2, or 6 divided by -2. That is a -3. Okay, so this is the equation in slope-intercept form. Now I can identify m and b. So right here, the number in front of x is m. That's 1/2. So slope is 1/2. And my b is this constant term that is -3. Okay, now just by looking at this, notice how their slopes are the same. Their slopes are both 1/2. And then look at their b's, their y-intercepts. Are they the same or different? Different, right? Now, if they had same slope, same y-intercept, we would expect them to be the same line, right? Because they would be identical lines. They would intersect at every point, and so therefore would have infinite amount of solutions. But if the equations have same slope and different y-intercept, they don't have infinite amount of solutions. We would expect them to have no solution, right? We're going to expect these lines to be parallel lines that never intersect, and therefore have no solution. So let's show that on the graph. So begin with B to graph the second line. I'm going to begin with B. B is at -3. So on the y-axis, I put a dot on -3 right there. And then my slope is 1/2. 1/2. And so like we did up here, I'm going to go up 1 and right 2. Okay, so from B, if I go up 1 and right 2, up 1, right 2. Or we could go down and to the left. So from B, down 1, left 2, down 1, left 2. Make your line here, insert line, click and drag. And then arrows on the end of the line to show that the line continues forever in both directions. And put a little 2 and circle it because this is line 2. Okay, so as you can see, there is no intersection, and they are like train tracks, right? They're like parallel, they are parallel lines that never intersect. So same slope, different y-intercept, parallel lines. And so what do we know about the solution? There is no solution. So we can add text box in here and we can type in no solution. There is no solution because the lines never intersect. They will never intersect. Okay, number 3 here, we have this system made up of 2 equations. The top one we can call equation 1, and the bottom we can call equation 2. Neither one of them are in slope-intercept form. And so let's take equation 1 and let's rewrite it into slope-intercept form. So equation 1 is negative 2x equals negative 8 minus 2y. I just copied it down. That way I can solve for y. I need y equals something. So notice that the y is on the right side. And so to get y by itself, I need to move this negative 8 to the left side. And so to do that, I would add 8 to both sides so that these 8s will cancel. Okay, so those 8s cancel because negative 8 plus 8 is 0. So over here you have, let me go ahead and put the x term first. It doesn't matter whether you write 8 minus 2x or negative 2x plus 8. That's the same thing. But I'll just put the x term first. Okay, bring your equal sign straight down. And over here you have this y term, which is not 2y, but negative 2y. Okay, then to solve for y, I would divide every term by the number in front of y, which is negative 2. So every term gets divided by negative 2. Every term gets divided by negative 2. That way, these negative 2 simplify to just one y, and so I'm going to put y equals, okay, I'm just putting y first, and then here I have a negative 2 over a negative 2. What's negative 2 divided by negative 2? That is 1, right? Or 1x. Don't forget your x. So this is 1x. Okay, what about your constant? Okay, your constant is 8 over negative 2. What is 8 over negative 2? That is negative 4, right? Negative 4. Okay, so this is slope-intercept form. I can now identify m and b. So m would be 1 or 1 over 1. And this is my b, negative 4. Negative 4. Okay, so let's graph this. So let's begin at b. B is at negative 4. So on the y-axis, remember this is the x-axis. This is the y-axis. So on the y-axis, I'm going to begin at negative 4. Right there, put a dot. Okay, and then I'll move with m. M was 1 or 1 over 1, which tells me to go up 1 and right 1. So from B, I'm going to go up 1, right 1, make a dot. 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 And I could continue. Okay, so it's insert line, click, and drag to connect the lines. And on the end of the line, be sure you put arrow to show that the line continues forever in both directions, of course. And put a little 1 and circle it. This is line 1 that comes from equation 1. Line 1 that comes from equation 1. Okay, now let's do the same thing for equation 2. So equation 2, put a little 2 and circle it. Copy down this equation. It's negative 2y minus 8 equals negative 2x. Y is on the left side, so move this negative 8 to the other side by addition. Notice how I'm showing every step of my work. These negative 8s cancel. Negative 8 plus 8 is 0, so you're left with negative 2y equals negative 2x plus 8. Okay, solve for y by dividing every term in the equation by negative 2, since negative 2 is the number in front of y. So every term gets divided by negative 2. That way, these negative 2's will simplify to 1y or just y. And here again, we have negative 2 over negative 2. Negative 2 over negative 2 is 1. And again, don't forget your x. This is 1x. And then for your constant term, you have 8 over negative 2, which is negative 4. Okay, so there's the equation slope-intercept form. And so this number in front of x is your m, your slope, and that constant term is your b. So m is 1 over 1. or just 1, and b is negative 4. So what do you see here? Same slope, same y-intercept. Same slope, same y-intercept. They're the exact same equation, right? They're both y equals x minus 4. And so if we were to graph line 2 would also look like this. So you can put a little 2 and circle it, because this line is not only line 1, it is also line 2. And so these we could say are identical lines. They are on top of each other. Okay, so how many solutions are there? Where do these lines intersect? Well, they intersect at every single point on the line, which is an infinite amount of solutions. And so the solution is an infinite amount of solutions. These lines intersect at every point on the line. So infinite solutions. Okay, last one here, number 4. We have this system made up of equation 1 and equation 2. Neither one of them are in slope-intercept form, and so let's put them in slope-intercept form and graph them so that we can identify what the solution is. So equation 1 is 2x plus y equals 1. Solve for y, so y is on the left side, so move this 2x to the other side by subtraction. So those x terms cancel, right? 2x minus 2x cancels. So right here is a positive y, so I'm going to put y equals. Now, do you see how I subtracted 2x from both sides? And so I put that minus sign. That is very, very important. If I just put 2x on both sides and don't put like plus or minus, then I don't know whether this term is positive or negative. So I must put minus 2x on both sides so that I can see I am subtracting 2x. And so therefore this is a negative 2x. And that 1 is a positive 1. So this right here is slope-intercept form. So now I can identify m. m is negative 2. Well, if I write this as a fraction, it's negative 2 over 1. That way I can see how I'm going to move with rise over run. And here is b. b is 1, positive 1. Okay, so let's go ahead and graph this. I'm going to begin with b. So begin on the y-axis at positive 1. This is x-axis. This is y-axis. I'm going to begin right here at 1. And then I'm going to move with m. m is negative 2 over 1. Okay, and this tells me to go what? To go down 2 and right 1. So let's do that from b. Down 2, 1, 2, to the right 1. Down 2, to the right 1. I could also go up and to the left, right? So from b, up 2, left 1, up 2, left 1, and make a dot. Okay, insert your line, click and drag, and there's your line. On the end of the line, of course, you put arrows to show that the line continues forever in both directions. Put a little 1 and circle it to say that's line 1 that comes from equation 1. Line 1 that comes from equation 1. Okay, now we got to put equation 2 in slope-intercept form. So I'm going to copy it down. This is 2x minus y equals 3. Okay, y is on the left side, so move this x term over here by subtraction. Okay, 2x minus 2x, that will cancel. Again, notice how I put minus 2x there and minus 2x there. I did not forget my subtraction sign, and I did not forget the variable. Must put both of them. Okay, that cancels, so here you have negative y equals, put your x term first. Your x term is negative 2x. And this 3 is a positive 3, so I'm going to put plus 3. Okay, not quite in slope-intercept form yet. Remember here, there's an invisible 1, and so I got to divide every term by the number in front of y, which is negative 1. So every term is getting divided by negative 1. Every term gets divided by negative 1. So that these negative 1s simplify to just 1y, or just y, which is what I want, so that the equation will be in slope-intercept form. Here I have a negative 2 over negative 1. I know a negative over negative is a positive, and 2 over 1, or 2 divided by 1, is 2. Don't forget your x. This is 2x. Your constant term, you have 3 over negative 1. 3 divided by negative 1 is negative 3. So this right here is slope-intercept form. Now you can identify m. m, of course, the slope is the number in front of x, which is 2, or 2 over 1. And the constant term is your b. So b is negative 3. Okay, so what do you notice about their slopes here? This slope is negative 2, this slope is positive 2. Are these the same or different? These are different, right? And you know right away when the equations have different slopes, there's going to be one solution. These lines will intersect at exactly one point. So let's begin at b. B is negative 3. Okay, so I'm going to put a dot at negative 3 on the y-axis, of course. So here's the y-axis. So I'm going to put a dot right there. The slope is 2, or 2 over 1. This tells me to go up 2 and to the right 1. So from b, up 2, 1, 2, to the right 1. Right there, right there is going to be the same point on both lines. I could keep going, up 2 and right 1, and put a dot. Insert line. Click and drag. Oh, that wasn't very good. So Control Z to undo. Click and drag. Okay. And of course, arrows on the end of the line to show that the line continues forever in both directions. Put a little 2 and circle it. That's line 2 that comes from equation 2. Here is my intersection right here. So how do I get to that intersection? Well, from the origin, I would go right 1 and down 1. And if I go right 1, that's positive 1 for the x value. So right 1 and then down 1, that's negative 1 for my y value. So that's the solution. Notice how my solution is an ordered pair that consists of an x value and a y value with a comma between them and put in parentheses. So from the origin, right 1, down 1. Solution is 1, negative 1.